So this is day 2 bell work. What does this formula, we've seen this formula, we've talked about it briefly. What is that formula going to give us? It starts with x equals the opposite of b divided by 2a. What is that formula going to give and do for us? Anybody know? Anybody recall? Look back in your notes. Yes, the axis of symmetry. Okay, and this is a quadratic trinomial in standard form. Okay, standard form. All right, so number 1 says identify the x-intercept, solution, zeros, and roots for the graph. Does that mean I have to find 4 different things for this graph? Is that what that means? Why not? Yeah, these are all the same thing, okay? They are different words that mean the same thing. All right, but before we can find that, we have to graph. And before we graph, we have to figure out A, B, and C. So what is my A value as I look at this quadratic function? Let me write it above here. So this is the same as y equals ax squared plus bx plus c. So my a value for this function is going to be how much? 1. Yes. There's nothing there, but we know that's a 1 understood, right? What's my b value going to be? -2. Very good. And my c value? -3. So everybody see where I got those? Okay. C is -3, B is -2, A is 1. Axis of symmetry says that x is equal to the opposite of B divided by 2A. Now, I don't know if we're going to give you this formula or not for the test yet, but I would start memorizing it, okay? X is equal to opposite of B divided by 2A. So, X is equal to, B is -2. So the opposite of B would be +2, all divided by 2 times my A value of 1. So that is 2 divided by 2, which is 1. So my axis of symmetry is x equals 1. X equals 1. Miss CD, do I really need to put that x equals in front of it? Yes, because it is a line, okay? So x equals 1 is your axis of symmetry, and I want you to go over to your graph, and I want you to put that dashed line over on the graph. Hi, Rose, stay with me. X equals 1, okay? The vertex. What do we know about the vertex? Where can we always find the vertex? That is correct. It will always be a maximum or minimum. What else do we know about the vertex? It is always what? Always on. It's going to be on the axis of symmetry, right? Always on the axis of symmetry. So if my axis of symmetry is x equals 1, what is the x coordinate of my vertex?
X. Did you say x -1?
No, x equals 1. So what's the x coordinate? 1, yeah. So it's got to be somewhere on this line. So x is equal to 1. Well, now I'm going to use this equation, this function down here, and I'm going to substitute x equal to 1 with the ABCs to try to figure out what my y value is. So f of x, the function when x is equal to 1 is equal to x squared, well, x is 1, so 1 squared, minus 2 times 1 minus 3. Does everybody see what I'm doing? All I'm doing is saying if I know x is 1, I'm going to substitute x in for, or 1 in for that x value. All right, so what is 1 squared? 1 minus 2 times 1 is 2 minus 3. So as I do this math from left to right, I have subtraction and addition. Should I do the subtraction first or the addition first? You should do whatever comes first from left to right, correct? So 1 minus 2 is negative 1, and negative 1 minus 3 is negative 4. So that value of negative 4 is the y value. So my vertex is 1, negative 4. Right there. That's my vertex. 1, negative 4. My a value was a positive 1. Does that mean it's going to be going up or down? It's going to be going up. So is this vertex a maximum or a minimum? It's going to be a minimum because the thing should go up. All right. Now, if that is the middle, I want to see what's happening to this parabola. 1 space to the right and 2 spaces to the right. So if the middle is 1, I want my x value to be 2 and 3. And then I want to check what it's going to be 1 space to the left and 2 spaces to the left. So that's where x is 0 and negative 1. Girls, you're ruining it for yourself to stay together. All right, so let's substitute 0 in for x. Okay, so if I say f of 0, putting 0 in, I get 1 times 0 squared plus, minus 2 times 0 minus 3. Well, 0 squared is 0. 0 minus 0 is 0. And 0 minus 3 is going to be negative 3. So my point here is 0, negative 3. Thank you. And as I look at this, this is a parabola. So whatever happens on one side, it's going to be exactly the same on the other, right? So if this 0 is at negative 3, this 2 is also going to have a coordinate of negative 3. Because they're going to have the same y values. So on the other side is going to be 2, negative 3. Then I have an option of finding the function at negative 1 or 3. So I'm going to choose, what do you want to do? Negative 1? Let's see. The function of negative 1. So I'm going to substitute negative 1 in for x is equal to x squared is negative 1 squared minus 2 times negative 1 minus 3. What is negative 1 squared? What is it? It's negative 1 times negative 1, which is 1. Ajobo, come on, head up, please. Negative 1 times negative 2 is a positive 2, and then minus 3. Addition and subtraction, you go from left to right. 1 plus 2 is 3. 3 minus 3 is 0. So that means my y-coordinate is negative 1, 0. And my y-coordinate for 3 is also 0. So they are going to have the same y values. because it's the same exact thing. It's like a mirror image on both sides. So now I have my parabola, and I can connect those 5 points. And there it is. Okay? So the x-intercepts, the solutions, the zeros, or the roots, as I look right here, I want you to circle them on your graph. And what points are those? It's kind of hard to tell. Can you tell? -1 and 3. So this is -1 and 3. Or you could write it as -1, 0 and 3, 0. But that's where my graph crosses the x-axis. Those are the roots. This is a root. This is a root. Okay? Questions on any of that? That's a lot. All right? Especially when you have a table, you need to substitute values in and try to figure out what is the y coordinate of that point. Any questions about number 1? You have on your homework for tomorrow 3 of these on the back. We're going to try to do one of them together at the very end, okay? All right, let's take a look at number 2. It says identify the x-intercept solutions in zeros. I want you to circle them first. Circle them first on your graphs and then write them down. Because when you circle it, you pinpoint it visually for yourself. So where do I find the x-intercepts in general? Yeah, it's where the graph crosses the x-axis. So circle those points. And what are those points? Looks like -1 and 2. Is everybody with me on that? So that you could say -1, 0 and 2, 0, or you can just say -1 and 2. Questions on that? All right, let's take a look at the second problem. Identify the x-intercepts. Miss Sadie, there's nothing that's crossing the x-axis. So that means this has no real roots or no real solutions. 0. Because that graph does not cross the x-axis. Now, it has some imaginary roots, but we're not getting into that yet. And the last one, gentlemen, stop the talking. The last one. How many times does it cross? Where does it cross the x-axis? Right there. And what is that x-intercept? 4. Or you could say 4, 0. So number 2 was a lot easier than problem 1, wasn't it? Yeah. Any questions about problem 2? Okay, let's set this to the side. Take out your notes. We're going to finish up our notes on section 12.1. The vertex would also be 4 for that one. And the vertex for this one would probably be 0.5, -4.5.
No, for number 1.
Oh, vertex. Oh, we didn't write that in. Vertex should be 1, -4. The vertex for number 1, looks like I boxed it, but I didn't write it here. Should have been 1, -4. Right here. All right, so your notes. I think we are on page 3, maybe? Or maybe we finished 3? We are at the bottom of page 3. So this might be why we were having a little bit more trouble with the axis of symmetry. We didn't get through this part. So finding the axis of symmetry given an equation says x is equal to the opposite of b divided by 2a. Okay? The example says find the axis of symmetry for this function. So I need to find my a, my b, and my c values. Ready? Give me the a. Oh, 2. Come on, a little more enthusiasm. Give me the b. Give me the c. What's it spell? Abca. Abca. All right. We've had our fun. All right, so the axis of symmetry follows this formula. Opposite of b all over 2a. Opposite of b all over 2a. So x is equal to, if b is 6, the opposite of b is going to be what? No. If b is equal to 6, what's the opposite of b?
I didn't say that. Shut up.
Hey, Ajobo, we don't talk like that in class. Maybe out in the hall, not here in class. All right, people, this is not as hard as you're making it. If b is equal to 6, what is the opposite of b, or the opposite of 6? Negative 6, yes. Divided by 2 times my a value. Here's my a value, so that's 2 times 2. So that is negative 6 divided by 4. Can I simplify that? Yes. Divide by 2 over 2. So negative 6 divided by 2 is negative 3, and 4 divided by 2 is 2. So the answer is negative 3/2. Is that correct? No. Because it is an axis of symmetry, it is an equation. You have to say x equals negative 3/2. Okay? Because we're talking about a line. Now, you might be like, where is negative 3/2? Well, if you take 3 divided by 2, you're going to get 1.5. So x is equal to 1.5. That's the same thing. These are the same. But any questions on how to put numbers and values into this equation to get the axis of symmetry? All right, so let's go to letter A. It says, find the axis of symmetry for the following quadratic functions. I need to figure out first, is this in standard form? You have to have it in standard form first. So, is it in ax squared plus bx plus c form? Is it in standard form? Yes. So, what is my a value? Give me the a. Give me the b. Negative 12. Negative 12. Don't forget the negative. And give me the c. 15. Very good. And the formula says x is equal to the opposite of b all over 2a. So if b is negative 12, the opposite of that is going to be positive 12 divided by 2 times a is 3. So that's 12 divided by 6, which is equal to 2. So my axis of symmetry is x is equal to 2. Questions on that? All right, I want you to try B on your own at your seats. You need to find your A, B, and C values first. Substitute those in. See what you can get. I'll come around. Make sure you know how to do this.
What? Bumble blood.
Find your passage here behind verse 3 and fill it out. All right. Fredderly, hey, I know you just came from a big test. So you need to keep working, okay? Important. I want you to do well in here, because I know you can.
Is this right?
Okay, come on, we need to go to the next one. I believe it is. Is it negative or positive? I don't remember. Let me check as we go through it. All right, let's see how we did. So, let's see. Give me the A value. 1. Give me the B value. And the C value. -2. And the formula for the axis of symmetry says x is equal to the opposite of B all over 2A. I feel like I'm losing my voice. So if B is 8, the opposite of B is going to be -8 divided by 2 times A, which is 1. That is -8 divided by 2. So x equals -4. How many had that for an answer? And the math teacher goes wild. Yes. Good job. Any questions about how to find axis of symmetry? Please remember that formula. All right, let's go down to the bottom. This is all we have for the rest of our notes for today. Says, identifying roots from a graph. State the roots and vertex for the following functions. I want you to circle the roots first, and then I want you to put a point on the vertex. Do that first. So circle the roots, and then put a point on the vertex. So remember, these roots are also called solutions, zeros, and x-intercepts. So here's what you should circle, and here is your vertex. So as you look at that first picture, what points did you circle? -3 and 1. How many had -3 and 1? Nice. And the vertex is like the cherry on top of the ice cream cone. Or, have you ever heard where you have an ice cream cone? Now I know a cone is kind of pointy and not U-shaped, but they'll put a Whopper in the bottom of the cone so it doesn't leak out. Have you ever heard that? No? So I call the vertex either the cherry on top or the Whopper at the bottom. This time it's at the top, and what are the coordinates of my vertex? No. No. I heard a lot of choices. No. -1 and 4. Because you have to go on the x-axis first, and then you go up. Right? You have to crawl as a baby before you can stand up and jump up or down. All right, I know this isn't on there, but what is my axis of symmetry? You should be able to get that. What is it? I did not hear that. Okay. All right. Thank you. What's up, man? What's up? Okay. All right. What is my axis of symmetry? What is always on the axis of symmetry? The vertex. So couldn't you go like this? Yeah. This is your axis of symmetry. And we know it's always x equals, well, where does it cross the x-axis? At -1, right? Didn't ask that, but that's a little extra. All right, questions about that first problem? Okay, go to the second problem. I want you to circle your roots and mark your vertex. Mark a point for your vertex. Quick, quick, quick. Do it, do it, do it. You can do it. Put the phones away. All right. Devion, I'm coming to you. Where would I find my roots? Not 2, but -2 and not 5. 6, yes. -2 and 6. How many had -2 and 6? Yes. And the vertex. This time it's the whopper at the bottom of the cone. What are those coordinates? 2, -8. 2, -8. Put them and give them a nice mathematical hug. Put them together. And what is my axis of symmetry? -2? It's not just 2. We have to be very precise. It's a line, right? So, what is it? X equals 2. X equals 2. All right? Any questions about anything on this page? All right, take out your homework.
Can I get a new one on both?
You can get a new one. It's the last one at the right below the yellow goldenrod. All right, let's go to the back. I want to do the back top problem with you just to make sure that you are able to do this. And this is due tomorrow, front and back, due tomorrow, okay? So I'm on the back side looking at number 6, and it says graph the function. First of all, is this in standard form? Is it in ax squared plus bx plus c form? Yes. So now I can find my a and b and c. So a is equal to -2, b is equal to -4, and c -3. Noelia is on it. She's like, come on, let's go. Give me something harder. The axis of symmetry. I need to use that little formula. X is equal to the opposite of b all over 2a. So if b is -4, what's the opposite? 4 divided by 2 times a, which is -2. So that is 4 divided by -4. Watch those signs. And that is -1. So the answer is -1? No, it's x equals -1. X is equal to -1. So put that on your graph. That is the axis of symmetry. And we're going to label it. X equals -1. Oh, wait, what is that? There is some point that's always on the axis of symmetry. What's that called? What's that called? The vertex. Yes, and the vertex is going to go in this box right here. If the vertex is on that line, that means my x coordinate is -1 because it's on that line. All right? Now, I got to find the y coordinate of that vertex.
Yeah.
How'd you get that?
Because it's not above the x line, it's not under the x line, it's over the x line, so it's 0.
I don't know that we know that yet. I need to take this -1 and substitute it in for x. So I'm going to say the function when x is -1, and I'm going to do this one and write it out. I'm looking at this function right here. So -2 times x, which is -1 squared, -4 times -1 -3. Does everybody see where I got that? I'm taking this function, this equation right here, and I'm substituting -1 in for the x. So now I need to simplify. I need to do my exponent first. -1 squared is, no, -1 times -1 is 1, and 1 times -2 is -2. What is -1 times -4? -1 times -4 is +4 minus 3. Do I add or subtract? Well, they happen at the same time. You look at it from left to right. So -2 plus 4 is 2, and 2 minus 3 is -1. So this -1 is the y coordinate of the vertex. So -1, -1 is my vertex right there. Now, as I look, I see my a value is -2. So is this going to open up or is this going to open down? We know it's going to be opening down, okay? So keep that in mind. I need to go 1 space and 2 spaces to the right to see what's happening here. We know it's going down. So if my x coordinate is -1, 1 space to the right is 0, and 2 spaces to the right is x equals 1. 1 space to the left of -1 is -2, and 2 spaces to the left would be -3. So we're not using our fab 5 here, but I'm just going 1, 2 spaces to the right, and 1 and 2 spaces to the left, because I want to see what's happening close to that axis of symmetry, okay? So let's do 0. 0 is easy. If you substitute 0 in, okay, I get -2 times 0 squared minus 4 times 0 minus 3. So 0 squared is 0 times -2 is 0. 4 times 0 is 0. Minus 3 gives me -3. So the y coordinate there is -3. Frederly, please take advantage of this and write it down. And then let's plot that point. 0, -3. 1, 2, 3. Right there. Because this is a parabola, it's going to look the same on the other side of the axis of symmetry. So over here, this -2 is also going to be a -3. They're going to have the same y values. Does everybody understand what I'm saying? So I'm going to go 1 down or 1 to the left and 2 down. All right, so then I'm looking at 1 and -3. I know they both have the same y coordinate, but if I substitute in with 1, that's easier than -3. So the function of 1 is -2 times 1 squared minus 4 times 1 minus 3. 1 squared is 1. 1 times -2 is -2. -4 times 1 is -4. And minus 3, -2 minus 4 is -6. Minus 3 is -9. So if 1 is -9 for the y coordinate, -3 is also -9. Plot those points. -3, 1, 2, 3, -9. Should be right there. And 1, -9. Okay, make your gentle curve of the parabola. And it says, find the y-intercept. The y-intercept is when your x is equal to 0. So the y-intercept is 0, -3, or -3. You can look at the graph and see that, or you can get it from the table. Okay? All right. Hopefully, between this and the bell work, you should be able to do the next two problems. And don't forget to do the front if you haven't done all of the front. When is this homework due? Tomorrow. Tomorrow.